When you're getting started, it's usually a good idea to start out with small trials and try, multiple different things to see which species is going to do best for you.
In this bonus episode, NCAT Sustainable Agriculture Specialist Colin Mitchell, who works out of NCAT's Southwest Regional Office in San Antonio, Texas, sits down with Stephanie Kasper, a biology research associate at the University of Texas at Rio Grande Valley. They discuss ways to ensure successful nodulation of legume cover crops. This podcast is part of the NCAT Subtropical Soil Health Initiative, funded by a USDA Natural Resources Conservation Service Conservation Innovation Grant. Let's listen.
Hi all, my name is Colin Mitchell and I'm a Sustainable Agriculture Specialist at the National Center for Appropriate Technology Southwest Office based in San Antonio, Texas. Today our guest is Stephanie Kasper, a Biology Research Associate from the University of Texas at Rio Grande Valley. I'm lucky enough to work with Stephanie. She's a fantastic scientist and a humble, super smart, dependable colleague, and really just such an asset to have on our team. We here at NCAT work with Steph and the rest of the UT Rio Grande Valley team on our Subtropical Soil Health Initiative, which focuses on research and education around cover crops and other methods in row crop farming systems to improve soil health in subtropical semi-arid regions. The lion's share of our work takes place in the lower Rio Grande Valley of Texas on the U.S.-Mexico border. And in this episode, Stephanie and I will discuss legume cover crops, how they get nitrogen into your soil, and troubleshooting strategies when your legume cover crops are not nodulating. Steph, thank you so much for doing this podcast.
Yeah, thanks for having me, Colin. I'm really excited, always looking for more excuses to talk about leguminous cover crops. Pretty much my favorite thing to talk about. So
that's great. Yeah, I consider you our legume expert, so I thought you were the perfect person for this. So just so people can learn more about who you are, Stephanie, what led you to become a researcher focused on soil and health and cover cropping and row crop systems? How did you kind of get to where you are today?
So I kind of started down this journey. I started out as a farmer with a lot of questions. So I was working on a small family farm in Edna, Texas. It's kind of in the Houston area. So I started out on my journey to becoming an agricultural researcher by first starting out as a farmer, and one with a whole lot of questions about how to be a better and more efficient farmer. I was working on a small family farm in Edna, Texas, kind of in the Houston area. We were growing organic fruits and vegetables for mostly the Houston restaurant scene. And I was always looking for ways to make better decisions while we're farming. It was the sort of farm where we really valued soil health and we're trying to promote soil health. But I realized, when we had people out on the farm and they asked, more than just the basic questions about soil health, that I had a hard time answering them. That, the scientific foundation for those answers wasn't something that I'd had a chance to learn yet. During that time, I ended up at a conference at the Texas Organic Farmers and Growers Association conference, and I ran into Dr. Alex Rosellis. He's a professor at UTRGV, and he leads the agroecology lab. And I was just listening to him talk about his work, working with farmers, doing participatory research. And so the idea of his program is listening to the questions that farmers in his area have, and then working with them collaboratively to help answer their biggest questions. And so I just thought the idea of that was really appealing. That was some work that I really wanted to be involved in. And so I left the farm, moved down to the Rio Grande Valley, did a 2-year master's program in sustainable agriculture with Dr. Rosellis as my advisor. The first 2 years, that was when the Subtropical Soil Health Initiative project was just getting started. And so I got to do my master's work as part of that project. And when I finished my master's, I got the opportunity to stay on staff as a research associate. And I really jumped at that opportunity. And I'm really happy to be able to continue doing that work, listening to the farmers in our area and trying to help find good answers to their questions about soil health. Ultimately, I'm still a farmer with a lot of questions, and I just have some better tools and resources for helping answer those questions now.
Yeah, that's great. Yeah, I didn't realize that's how you and Dr. Rosellis had met. It's a great little origin story, and I'm glad that, you were able to stay on with the project and with UTRGV. Just such an asset, both our project and I know to Dr. Rosellis and the the agroecology program down there. So that's great.
Really good to be able to see the project start to finish, from the very first cover crops we put in the ground to here we are at the end of it, and trying to analyze the data, figure out our big conclusions for the last 4 years. It's been good to see the journey kind of all the way through on this project.
I think you'll be working on that new Conservation Innovation Trials grant that NRCS has funded to kind of continue this work, right?
I think so. I haven't heard that for sure, but I think I'll definitely be around.
Yeah, I imagine you'll have something to say valuable in there. All right, so let's go into our cover crops. So we're going to be talking leguminous cover crops. Can you explain to our audience what the importance of having a legume cover crop in their crop rotation? Like, why is that important?
So there's kind of two parts of that there. There's the leguminous part and the cover crop. So I'm going to talk about the cover crop part first and the importance of cover crops. Cover crops are basically any crop that you're growing not to harvest a yield off of it, but as an investment in your future soil health. And so that works in a few different ways. There's a kind of a number of benefits that can come from cover cropping. One, having roots in the ground and ground cover for a higher percentage of the yield of the year, that can help reduce soil erosion both by wind and by water. Cover crops and having a nice canopy cover that can help with weed suppression. You're reducing the amount of light that's getting to the weeds. Cover crops can also help increase organic matter, which can feed microbial activity and over time help improve water holding capacity. Cover crops are also great for helping disrupt pest cycles. So then there's the other part, the leguminous part. Legumes are kind of special among the different cover crop options. The reason that they're special, it comes down to nitrogen. So lots of other cover crops can help scavenge soil nutrients, but mining deeper in the soil layers for soil nutrients. But legumes are the ones that can increase soil nutrient levels. They're taking nitrogen that's in the atmosphere that plants can't access and turning it into a form that plants can use. So you're increasing the soil nitrogen levels for the subsequent crops.
So what are some examples of some legume cover crops, especially let's say for the subtropical region, since that's our research and focus area? What are some of these legume cover crops that a farmer could use in their system?
There's a few different options for warm season cover crops. Some of the ones that we've tried have included velvet bean, mung bean, soybean, guar, cowpea, and sun hemp. And the two that have really been the most successful for us in the hot Rio Grande Valley summers have been cowpea and sun hemp. Those are our two leguminous cover crop winners from our trials.
Basically, the legume cover crops are more in that pea bean family, correct? As far as like annual crops, we're not getting to nitrogen fixing trees or things like that.
Right, yeah, especially for cover crops, you want things that are going to germinate and grow quickly and then be easy to kill and get rid of so that you can clear them out of the way and have a clean field to plant your next cash crop in.
Okay. Can you explain the process of how legume cover crops put nitrogen in the soil? Like, what is nodulation and how does that get from, you putting that legume in the ground to you get nitrogen in your soil for next crop now? How does that work?
So the legumes don't do nitrogen fixation on their own. They do it in partnership with a soil bacteria called rhizobia. And each different legume species has a different bacterial partner that works with it to do nitrogen fixation. And so when you plant your legume seeds, they germinate and the little root tendrils start growing. The key here is that one of those roots has to come across the soil bacteria, this particular rhizobia. And then they do a little communicating back and forth, and that root tendril starts to curl around the bacteria. And it makes a home for the bacteria on the root, and that's called a nodule. So there are these little bumps on the roots that provide an anaerobic environment for the bacteria to live and produce nitrogen. The plant is providing sugars, the food, and the water that bacteria needs to live. And in exchange, that bacteria is taking atmospheric nitrogen, converting it into plant-available nitrogen, and feeding it to the plant. So it's this partnership between these two species. a biological partnership. When all of that is working properly, if you open up, if you kind of cut into one of those bumps on the plant root, it'll be bright pink inside. And so that's the sign that your bacteria are alive and happy and well fed by the plant and producing lots of nitrogen. Because it's a biological partnership, if something goes wrong with either species, if you have either maybe your bacteria is not there or your plant's not very healthy, there are things that can go wrong that can cause the nitrogen fixation to be less than you're expecting or sometimes not even happen.
You already answered my question. Was going to be how can you tell if they nodulate? It's that little pink kind of, there'll be lots of them little pink balls kind of attached to the root, and that's how you know they're alive. And
something that we learned early on in this project, in the Subtropical Soil Health Initiative, is that nodulation doesn't always occur effectively. In our very first season, we had a beautiful cover crop of field pea, of hairy vetch, of crimson clover. They were nice and they were green and they were growing. And we all thought, oh my gosh, we're going to be getting so much nitrogen off of this cover crop. But then kind of closer to the end of the season, we were like, oh, let's dig some plants up and look at their roots. And they didn't actually have any nodules on them at all. And so we weren't getting the nitrogen benefit that we thought we were. And so ever since that season, that's kind of what led to my further research in the area of legumes and nodules. And we've made it a real habit in any of the cover crop fields where we're growing legumes to not just rely on the plants look healthy, they're very nice and green, but we actually go out there into the field, take a shovel with us, go to different sections of the field and dig up a few plants and just look and see, are there nodules there? How many? The more nodule material, the more nitrogen fixation can occur. And we're always making sure to look inside and see the color on the inside of those nodules. We're looking for that bright pink color. If they're kind of a more tan color, those sometimes are younger nodules that haven't started producing nitrogen yet. And if they're a kind of green-gray color, those are the nodules that they have completed their nitrogen fixation. They're not fixing nitrogen anymore. Those are dead nodules. And so we sometimes also use that as a sign that, the nitrogen fixation benefit, we've maxed out already, we can go ahead and terminate the cover crop. It often happens when the legumes are blooming, because just biologically at that point, the plant, it doesn't have any more sugar to spare. It doesn't want to send its sugar to the roots, to the rhizobia, to feed the bacteria. It's focusing its sugar instead on flowering and making seeds. So that also lines up with when a lot of people are thinking about terminating cover crops anyway, when you hit that 50% flower point.
Okay, so at what age should our farmers start kind of pulling up plants to check to see if they've nodulated?
By around 30 days after seeding, the nodules should have formed and be pretty visible. So if you don't have nodules at 30 days, you're pretty unlikely to have nodules for that cover crop.
So would that be 30 days from seeding or 30 days from kind of sprouting and emergence? Because, I guess it kind of can depend on rainfall, as we know with our droughty conditions, though typically it doesn't rain for 30 days. A lot of our seed does cook and become inert if it's, the summertime or September.
Yeah, that's good to clarify. Probably 30 days after germination.
So let's talk actually inoculating the cover crops. I know this is pretty essential to nodulation success, unless you have the exact right native rhizobium in the soil, which is pretty rare and leaves a lot of chance up to what's in your soil, and you could end up wasting not wasting money, but not getting the optimal results you want from the legume cover crop you planted. Can you walk us through the process from purchase to planting when inoculating cover crops?
Yeah, you're absolutely right. Inoculation, which is adding the correct bacteria, the correct rhizobia that matches your leguminous cover crop species, is really important for getting good nitrogen fixation results. When you're buying seed, generally whoever you're purchasing seed from, if you're buying legume seeds, they should also have the matching rhizobia. You'll usually be getting that in the form of these packets that have powdered peat in them. And so it's a powdered peat material with those rhizobia inside. That package, it's really important to remember that it's alive and that you need to keep it alive until you're applying it to your seeds and getting in the ground. And so the ideal storage temperature for the rhizobia is between 40 degrees Fahrenheit and 80 degrees Fahrenheit. It's really easy to forget when you're like, out in the truck of the field. It's like toss that inoculant packet up in the dashboard of your windshield. But it's really easy for them to overheat. And anytime they're outside of that 40 to 80 degree temperature range, you're losing rhizobia viability. So they're just, gradually dying. And if you get to the point where there aren't very many live rhizobia left in your inoculant, you're not going to have good nodulation success. The other thing is the rhizobia inoculants, they have expiration dates on those packets. It's usually about a year after purchase. So you do want to pay attention to those dates. And if you get too far past the expiration date, you'll want to try to buy fresh inoculant. Because after about a year, the number of viable rhizobia really starts to decline as well. So we've gotten the correct rhizobia, and we've done our best to keep them alive. Next step is to actually inoculate the seeds. And you want to do that as close to seeding as possible. Sometimes you'll see on the market pre-inoculated seeds, and those can be really tempting because you're like, oh, I can skip the step of inoculation. That'll save me time. That's great. But for a lot of species, the pre-inoculated seeds, those rhizobia don't survive on the seed very well either. So you're losing nodulation potential. So if you can avoid the pre-inoculated seeds, do it yourself, even though it is a little bit of an extra step and a little bit of a hassle, and do it within, a day or two of when you actually plan to plant those seeds. A lot of folks will just mix the dry powdered peat material in with the seeds. Sometimes the peat material will fall off of the seed. And so when you're planting, you're thinking about how am I going to keep nice contact between my inoculant and my seed all the way until it gets into the ground. You want those guys in the ground together so that when that seed starts to grow, it'll definitely encounter some of those rhizobia. And so we had a student do some work in the lab on substances that can help stick the rhizobial inoculant onto the seeds a little better. They're called sticking agents. The two that she had the most success with were gum arabic and just like basic vegetable oil, peanut oil. Both of those can help really keep the inoculant stuck onto the seeds really well. If you're doing it at a small scale, it doesn't really matter if the seeds are kind of wet and stick together a little bit, that's okay. But if you're working on the large scale with big tractors and seed boxes, if your seed goes in wet, that can cause some problems with clumping. And so something that we've done is get big tarps out and inoculate on the tarps. Kind of want to do that in a shady area so it's not getting too much direct sunlight. Give them a little time to dry out and then put those somewhat dried out seeds in the seed box and plant from there. Yeah, you want good seed to inoculant contact and to get the inoculant into the ground with those seeds to maximize success.
Yeah, and just for the audience, we do have some videos that we made for this project, the Subtropical Soil Health Initiative, on our YouTube channel. And if you just search Subtropical Soil Health Initiative, it should come up as a playlist. And we have some visuals that kind of match what Stephanie was talking about with inoculating the cover crop on a tarp and getting it ready to go. Thinking about our organic producers, can they just buy any old inoculant, or is there a specific inoculant for organic producers?
That's a good question. I'm not sure that I know the exact answer. I know most of the inoculants that I've seen are OMRI certified. I'm sure there could be some brands of inoculants that have some other additives going along with them that would not be OMRI certified. So definitely good to check on. It's going to be a brand by brand basis and make sure with your certifier if you're working for organic certification.
Whoever you order your legume cover crop seeds for, you can typically get the inoculant from them as well. So let's move on to some troubleshooting. So let's say, you're a farmer listening, you did everything right, You got your planting depth, your timing, your inoculation technique, right? What are some things farmers listening should be troubleshooting to figure out what is causing nodulation failure? Because even if you do everything right, there still are things that could potentially cause nodulation failure, correct?
Yeah, correct. First, even if you do everything in inoculation right, there's still a chance that you just got a bad batch of inoculant. There isn't any quality testing requirements in the inoculant industry in the United States. There are in some other countries like Australia, but in the US, the inoculant industry is in charge of its own quality control. And so there's no way as like an individual farmer without access to a microbiology lab that you can check the quality of your own inoculant. So you can never quite rule out that it was just an inoculant problem. But some other areas where you can run into problems, and we've run into some problems. One thing that can happen is if your soil nitrogen levels are already too high, so that's kind of above 60 to 70 pounds per acre, the plant doesn't need the nitrogen from the rhizobia. And so like the plant, it knows that it's picking up enough nitrogen from the soil. And in terms of its, sugar allocation, it's going to withhold sugars from the rhizobia and use those sugars for, plant growth instead. If the nitrogen levels are too high, that's one thing that can keep nodulation from occurring. So in that case, you still get all of the other benefits from cover cropping. You get the biomass, you get the organic matter, you get the weed suppression. Just you already have really nice nitrogen levels, so you don't get the nitrogen boost from legumes in that case. If you already have high nitrogen levels, you might be better off saving a little money. Legume seeds often tend to be a little more expensive than other kinds of cover crops, so you could get away with using, some grasses or some brassicas in that case instead. Another thing that can happen, you're pretty confident that your nitrogen levels aren't high enough to cause any problems with nodulation. A big problem that we have in the Rio Grande Valley, we're a semi-arid area, and our farmers, especially the ones without irrigation, are really moisture limited. And so if you don't have a whole lot of soil moisture, that can cause some big problems with nodulation and nitrogen fixation as well. Again, if you think about it from the plant's perspective, the bacteria, they're providing this really valuable service of nitrogen fixation, but they're not essential to the plant. So if you're a plant and you start to experience moisture stress, the very first thing that they cut off the water supply to is those root nodules, because they're conserving water for the rest of their plant functions. The water levels are especially key during the early phase of cover crop growth, during that nodule formation period. If things get extra dry, then you'll also have problems with cover crop germination in the first place. But there's kind of that middle ground where you have enough water to get the cover crops to germinate, but not enough water to get the nodules to form. And if you're a dryland farmer just relying on rainfall, there's not too much you can do to solve that problem. You just got to wait for rain. So those are the two big ones that cause a lot of nodulation failure: too much nitrogen or not enough moisture. A few other things that could be going on: soil pH can play a role. The bacteria in particular they don't like acidic soils. So if you get much lower than 5.5 pH, the rhizobia are going to have a really hard time surviving. If you have saline soils, that can also cause some problems. Legumes vary a little bit, species to species, in their salt tolerance. So if your soils are more on the saline side, and you have some species of legumes that have a nodulation failure, you could be able to fix that one just by switching over to a different, more salt-tolerant legume species. And then another thing that can happen is nutrient deficiencies. Some of the ones that are particularly important for nodules are molybdenum, copper, cobalt, zinc, boron, and manganese. And one final thing that can happen if you have a fungicide in the soil, or especially a seed treated with fungicide. Fungicides can be toxic to the rhizobia and can kill off the rhizobia before they ever have a chance to form nodules. So a number of things that can go wrong, but kind of the big three that you want to really pay attention to are that inoculation process, start to finish, nitrogen levels, and the moisture levels.
To go back to the nitrogen levels, do farms that have maybe been switching from a really high input, putting down lots of nitrogen fertilizers, can these farms start in the initial first couple of years? Will they have trouble getting their legume cover crops to nodulate? Is that like a potential issue for them?
Yeah, that definitely is a potential issue. Over time, like the longer that you've been off of high levels of synthetic nitrogen, the less likely it is to be an issue because your nitrogen levels are gonna, fall a lot lower. And once the nitrogen levels are lower, then the legumes have a lot better chance of nodulation success.
Okay. And then the other thing you mentioned was, the fungicides and the treatments. A lot of cover crops you see, for conventional systems are treated with different fungicide applications or, seed coating treatments. Is this almost counterproductive if it's a legume cover crop that you're trying to, get nitrogen fixation from?
Yeah, it could be. It depends a little bit on the specifics of the seed treatment, but there are a few of them, especially those fungicides, that'll have negative interactions with the rhizobia. So if you can find, at least for the legume seeds, untreated options, it improves the chances of success there.
How would you recommend a farmer who wants to, they haven't used cover crops before, they're just dipping their toe into using, legume cover crops. How would you recommend that they get started?
So I think the first thing to think about is what time of year do you have like a fallow period or an opening in your crop rotation where cover crops might fit? Are you thinking of cover cropping in the cool season or the warm season? Here in the Rio Grande Valley, our warm season is about 8 months long. So we're usually cover cropping in the warm season. And for legumes, that would include, cowpea, sun hemp, velvet bean. And in the cool season, some of the options are more like clovers, hairy vetch, field peas, maybe lentils. So you're thinking about what time of year and matching the legumes that are going to be, healthiest and happiest during those times of years. And then the other thing to think about is, so here in the valley, we've had really good success with nodulation for sun hemp and cowpea. Those have formed nodules really well for us almost anywhere we put them. But we've had a lot more nodulation trouble with some of the more temperate species, with the clover, vetch, and the peas. So it's just helpful to, test out smaller blocks and learn which ones perform better or worse for you before you go out and plant 100 acres and then wind up really disappointed if they don't form nodules and provide the kinds of benefits that you were hoping for.
Yeah, that's super helpful advice. Don't go out and plant 1,000 acres of cover crops that it doesn't work. It's that's something we really advocate for. When you're trying anything and to build soil health or regenerative agriculture, refine it and test it out before you go all in on it and spend thousands and thousands of dollars on it.
Yeah, absolutely.
Alrighty. Well, thank you again, Stephanie. This was great. And you can find more of our resources for the Subtropical Soil Health Initiative on our ATTRA website or our NCAT.org under the Agriculture section. We have a website with all of our resources for the Subtropical Soil Health Initiative. In addition to thanking Stephanie and the University of Texas Rio Grande Valley, I did want to take the time to thank our partners at NRCS, this is an NRCS-funded project. A specific thank you to the NRCS Central Technology Support Center. They've been incredibly supportive during this project, and this project is supported by the Conservation Innovation Grants Program of the USDA Natural Resources Conservation Service, and it has been a great opportunity to get to do this work with University of Texas Rio Grande Valley, and of course our amazing farmer partners down there in the Rio Grande Valley. So just thank you again, Stephanie, and hopefully I can get down there and see y'all soon.
Sounds good. Thanks, Colin.
All right, thank you.
Well, that's it for this episode. Thanks for listening. Additional information can be found in the notes. And please leave a comment and don't forget to subscribe. We'd also appreciate it if you could fill out a brief survey to tell us what you thought of the podcast. It helps us improve our content. A link to the survey is included in the notes. I'm your host, Rich Myers. Alan Puckett and I produce ATTRA Voices from the Field at the National Center for Appropriate Technologies headquarters in Butte, Montana, with support from the USDA Rural Business Cooperative Service as part of NCAT's ATTRA Sustainable Agriculture program. Any opinions, findings, conclusions, or recommendations expressed in this recording are those of the participants and do not necessarily reflect the view of the USDA or NCAT. We'll catch you again next week, and until then, keep on farming.